I'm a professor at the Hostos Community College in New York. Hostos Community College is situated in South Bronx, which serves primarily, I would say, Latino community, as well as many people are coming now from Africa. This is a college that serves essentially working class of South Bronx. And in fact, our interest in creativity was motivated precisely by our desire to address, to understand, and to facilitate creativity of our students, which we had to do in a rather unusual way, namely by investigating and by using the illumination of aha moment insight. So the way this presentation will go is that I will sort of introduce some basic definitions of what is creativity, and there will be several of them, after which I will present several aha moments, right, together with the analysis and everything that I could say about them in the seminar. Yes, I'm sure that, well, I hope that there will be some questions during especially after the discussion of aha moments, and I welcome them, of course. We are still here in the process of learning, and any comments are highly, highly appreciated. So let me start maybe with the next slide, right? Here it is, right? And we are talking, as I mentioned, about the creativity of an aha moment. More or less, each of us knows and experiences, I suspect, this moment, right, when suddenly things become clear. That's a aha moment, and we will sort of get into it deeper. At this point, I want to point out that the title suggests two separate ideas. One is the creativity, another is aha moment, which I hope they will sort of integrate during the presentation. And so I would like to start talking about a bit how different people view this creativity, right? All of us know the word, right? But what is the meaning? It turns out to be maybe not ambiguous, but it's very rich. It's a very rich thing, right? And because of that, it can be looked at several different angles that sort of illuminate a particular set of ideas. Let me start with Paul and Kaufman, who are the authors of the first volume on philosophy of creativity in 2013. When they published it, philosophy of creativity was just a nascent enterprise. Well, here in the very first pages, they say, what does it mean creative? What is the meaning of the term creative, right? And they correctly say it could be used to describe a person, right? A creative person. It could be used to describe a creative process or activity, or it could be used to describe a creative product. Now, about the creative product, and which is the ultimate, right, the result of our creative activity. Well, they see two essential sort of qualities of the product. It must be new, and it also must be of value. And this question of value, right, and both questions, new to whom and of value to whom, right? And we will discuss at some point why am I making this distinction. The next sort of approach, the next definition is by Margaret Boden, who is really a researcher. She comes from artificial intelligence, right? Notice creativity is the ability to generate creative ideas, and creative idea is novel, surprising, and valuable. First, let me point out that she is here combining two elements, right? Ability to generate creative idea talks about the creator, the person, right? On the other hand, she also describes what to her is the creative idea. In other words, she talks about the product. So together in this definition, we have two components, right? One is the personal component, the ability to generate creative ideas. Another is the product component, right? Creative idea is the product of this activity. What is interesting, right, that for her, on the other hand, we have three qualities that she ascribes to creative idea. Well, it has to be novel and corresponds with the new for the Paul and Kaufman. It's also valuable, right? She recognizes the importance of being valuable. However, what comes new from Botan is the idea of surprising, that it would be good if this idea is not only new and not only novel, new, and not only valuable, but surprising. And that's kind of interesting that she points out to this. Because, well, why is it surprising, right? Well, in general, when we have aha moment, quite often, right? Quite often we are surprised by ourselves by it, because it's so different than what we have thought about. So to me, the quality of surprising is okay, right? It happens. On the other hand, we have here another definition, right, of Moruzzi, right? And she is interested in something else. She wants to pull out the common aspects of natural and artificial creativity, right? Well, artificial creativity is, of course, creativity of artificial intelligence objects or things, right? But also she says she would like to get at the inner structure of the system that produces creative outcomes, right? That it doesn't depend on external factors. Well, what external factors? Well, a teacher that works with a student, a book that we correspond to, that's not what she is interested. She is interested in the inner structure. How does this happen? And that's also what I am interested in this talk. We're going to be talking about the inner structure of aha moment, right? So she sees the creative system as having three qualities. Three qualities. One of them being problem solving, and we know, of course, that a lot of that many problems require creativity, require creative approach. She also is talking that a system of evaluation has a creative feature, and that's something to think about. How so? How evaluation, where evaluation of the idea, of the object, where does it have this creativity? And as I'm thinking about it, right, whenever we evaluate, we want to give some. What do we do, right? We give our opinion, our expression to something that we see, that we perceive, and it is by being our own, right? Has this originality, and of course, quite often it might be a new approach, new way of seeing it in the process of evaluation. So more or less, that's how I understand. I have some ambiguity about the evaluation as creative activity, and I would be happy to hear your opinion. However, what is more important here is that she includes naivety. I never know how to say this word, naivety, right? And that's interesting. Why is it interesting? Well, what is a person who is naive, right? The person who is naive is the person that is not sort of burdened in all the previous experiences, or maybe is not biased by the previous experiences, so that this person can approach the situation without preconditions, without without anything else, right? And that's very important. In fact, this ability to be fresh, to be naive in relation to the problem is a very, very, very important and very commendable feature, right? Because it allows us sort of a fresh look at the problems that we are looking for. And another thing that I would like to add in the problems, or in the problem in the when we want to facilitate aha moment in the classroom, and when we write about it, one of the main conditions that we state is that this particular subject was not discussed in the class, right? That in fact students are in the state of mind of being naive in a way in relation to this problem. Okay, so those are like three definitions which are sort of close to each other. However, now I would like to go to two definitions that are more sort of more, I would say, useful and important in the classroom, right? And what are they? There are two of them, right? Oh, this I forgot to take away. Okay. Anyhow, one definition is that, well, it comes from the Gestalt philosophy, Gestalt approach, right in the beginning of the 20th century. It was formulated by Wallace and Adamart. Wallace was a philosopher, and Adamart, we know he is he was important mathematician in France. And what is very interesting, he was a student of Poincaré, another extremely sort of like fruitful mathematician. And what is important to say about Poincaré is that he was the first that pointed out the unusual aspect of thinking about mathematical problems. In fact, he had a very important presentation to the French Academy in which he actually described several of those what I called aha moments. He might have called it eureka experience. And what is it very shortly, because I want to show those stages in actual aha moments. This is a four-stage theory, right? A theory of creative process. The first stage is the preparation, right? And you will see in a minute what is meant by it, but it's simply our work, right? I mean, our conscious work upon the problem, right? But what is important that after this conscious work, right, that usually doesn't work, there is a very important step, namely of going away from that work. Right? Because by going away from that work, we allow this unconscious or semi-conscious process of incubation of the idea. This is extremely important. It's probably the only system that talks about this process of incubation, right? After incubation, what is being incubated, right? We have illumination. It comes to light, right, as a aha moment. And the point is, however, and that was pointed out by Poincaré, that one cannot stop on this illumination. Actually, that is very important to check it, right? To check by verification. And he writes very, very strongly about it, simply saying, look, illumination can give us a direction. It can give us just the guide to what we do in sort of deep cases, right? But what is left to us, well, to really realize it, and that means to calculate or find out another way of doing it. So as I mentioned, this particular definition, which is used in in research, but I would say not extensively, because the main definition, main approach in mathematics education is provided by this Guilford approach, right? And Guilford approach relies on the concept of divergent thinking. Right, and I just would like to add that in order to make it really compact, the divergent thinking has to be accompanied by convergent thinking, right? Because it is the convergent thinking that helps us to formulate the ideas that comes through the divergent thinking. That's how I understand that. So according to Guilford and according to many of our colleagues, divergent thinking has the following characteristics. First, fluency, right? Fluency, and what is meant here by fluency is that in the process of solving a problem, we are able to come really fast with the different relevant ideas that are needed to push the solution further. And that is that's very important, but it's also that quality that forced us at the community college in New York to seek another way, because of course our students are not fluent in mathematics, but nonetheless we find out they are quite creative. So the question was for us how to get to the creativity in a way that doesn't depend on the fluency, because then we wouldn't get much. And the second idea is that of flexibility, right? And the flexibility is it is the ability to generate many different ideas, right? That's one solution, another solution, still another solution, this approach, and so on. This is actually this flexibility is most probably the main manifestation of divergent thinking, right? Whereas for me, fluency is rather already has an element of convergent thinking, right? The relevance is to me, it seems much more convergent than divergent, actually, in any case. And the last sort of quality is originality. And this is very important, right? Because that refers, of course, to the newness of the idea, but not only, right? It refers to the fact that the person came out from his original sources, his or her own original sources, right? Which ultimately come out. But what is interesting also, that together with this comes the a desire for elaboration, right? That is the ability to develop those ideas. And in my opinion, they are sort of connected to this verification that Poincaré insisted on. That Poincaré insisted on. Elaboration and verification seem to me close to each other. One other thing I would like to add, that this approach by convergent thinking has been developed in mathematics education by the group in Israel led by Rosa Leikin, right? And they really push this concept very much. My personal sort of objections to their work is that originality there is defined as statistically in the sense that person or that solution is original if it is unique among the whole, say, solutions of the whole class, right? So it is formulated relatively to the social environment, whereas I would like to see this originality, right, as deeply ingrained in the person who creates, right? Okay. Anything else that I should ask? Any questions, by the way, here? No questions. Okay, so let me continue. Let me continue. This is here, right? And then I have a next. Just before I will switch to actual discussion of aha moments, there is one thing that's very important that really enabled research into creativity of students in the classroom. Because for a very long time, as I'm sure you are aware of it, the creativity was associated with the concept of a genius, with someone really special, precisely like Poincaré in mathematics, Einstein, say Beethoven in music, and who else, right? And Van Gogh, for example, Van Gogh in the art, right? But what turned out to be the case, that it was realized that the concept of that the structure or the way one arrives at the creative moment by an inventor, by a mature mathematician, is not very different from the structure of the creativity of regular person, right? That's why C creativity with small c is also called personal creativity, right? And it impacts primarily an individual thinker, but not necessarily a society. In other words, this newness of the creative element is new for the thinker, not necessary, right, for the class, not necessary for the society at large. On the other hand, this capital C creativity, which is also called H creativity, historical, focuses on that creativity that has an impact on society at large. Here I sort of brought forward the important statement by Adamard, right, who says that between the work of the student who tries to solve a problem in geometry or algebra and the work of mature invention, one can say there is only the difference of degree, the difference of a level, but both works have similar nature, right? So the way I interpret it, right, is that the nature of creativity is the same, either for the genius or for the student in the classroom, right? And having discovered this, or having formulated, having realized this in the last 15 years, that was what made possible for us to really enter into the investigation of creativity in the classroom, in the regular classroom. Anything else here? No. So now I will go, no, not yet. I will present the next slide that already talks about aha moment, right? And it is based on the work by Arthur Koestler, which is called The Act of Creation, right? And it's a big volume, 700 pages, all of it devoted just to the moment of creativity. What is important, right? Of course, he talks about aha moment, he talks about eureka experience, and he gives this special name to it, bisociation. Below, just here, I have the definition of the bisociative act, and let's look what it contains. Right, it is spontaneous leap of insight, right, and we understand it's spontaneous leap, right? It's a leap because what happens there is that we don't understand, and then suddenly we do. Right, so there is a big distance between our knowledge before the aha moment and after the aha moment, and this distance is characterized by the leap. And it's also important that spontaneous, it comes out of our spontaneous thinking, our intuition, and so on, right? But what is the role of this leap of insight? It connects previously unconnected matrices of experience, right? Well, what are those unconnected matrices of experience? First, they are at least two, right? And it's bisociation is sort of formulated by Koestler as to distinguish itself from association, right? Association is generally within certain domain of knowledge, and he wants to emphasize that no, that the real thing comes not so much within one particular system of knowledge, but it has to be at least two. And the bisociative act, the leap of insight, connects, right? Connects the two unconnected matrices of experience. And as we'll go through the different aha moments, I will try to show which are those unconnected matrices of experience and what is the bridge, right? Because this connection is simply a bridge between those two. But there is one more information, right? And this is also very important because, well, he says it happens by the discovery of a hidden analogy, right? But soon after, he is asking now, where is it? Where is this hidden likeness? Where does it hide? And how is it found? And then he says something important. In most truly original acts of discovery, the seeing is in fact imagining. It is done in the mind's eye and mostly the unconscious mind's eye. And here he gives an example. The analogy between life of one kind of a microbe inside the cow and another kind of microbe in a forgotten culture tube, and he's talking here about discoveries of Pasteur, was not hidden, he says. It was created by imagination. Now, this is a very strong statement, right? And it is a part of a discussion that goes in the philosophy of mathematics, which asks, well, what is it? Do we discover mathematical facts or do we create them? Is it our creation, right? Or is it our discovery of something that exists independently of us? And this problem of existing independently of us or depending on us appears very strongly in physics and quantum mechanics, right? Where the point is that the measurement of something is not finished until it comes to our consciousness, right? And that means that we participate in a fundamental way in the process of measurement, not only as the experimenters, but also as people whose consciousness is important to finish the experiment. And let me just add that, of course, that was one of the main issues that Einstein and Bohr were discussing in the 30s on the meaning of quantum mechanics, where Einstein was the very strong proponent of the separateness of nature from the observer, right? And Bohr, of course, vice versa. I will not go with just what I mentioned because there is something analogical here. What else is there here? Well, that's what I wanted to say. So let me just go here. And what I want to say is that now I will be talking about different aha moments. And with each, I will try to point out the elements of different theories, the elements of what we talked about, so that those definitions and those concepts become a bit more, as they call it, embodied, right? That we know what we are talking about. So the first aha moment is called the aha moment elephant. Let me then change the slides, right? So here it is, right? This is a aha moment observed by it comes from Poland, actually, by a colleague who was observing two students, young boys, 10 years of age, right? And they were fighting with the problem. The sum of two numbers is 76. One of the numbers is 12 more than the other. Find both numbers. Of course, all of us know those problems, right? And so on. Okay, and there are two of them. One is Przemek and another is Bart. And what is here is the dialogue that leads to the aha moment. And notice that the problem is essentially simple. Well, not simple, but standard, right? X plus 12 equals 76. So Przemek understood it rather fast, right? And then he was explaining to Bart, who, as you will see, was quite resistant to the process of understanding, till something happened and he just grabbed it just like that. So here Przemek first tries to explain it to him, using intervals, right? It's a common way, right? Probably from the book. So he says, here you have one interval, then you take another interval, and this added to 12 should be 76. And Bart repeats this. So all together is equal 76. Then Przemek says, no, it's an equation. They understand? No, Bart doesn't accept it. Why interval? If you don't know it, what is supposed to be, that's unimportant. By why 76? Because it's in the problem. Bart has a resistance to it, right? So then Przemek tries a different approach, right? Different approach to explain, and namely says, look, instead of x, write a little square like it is in the book, right? So you have one square, another square. I even put parentheses here and parentheses here, so it corresponds to the problem. And this is equal 76, but still Bart cannot grab it. Look, it's written something else here, he says. But well, it could be here, right? And now I am putting a number into it. What number and why in the square? Forget about the square. It's into the window, and into this window I put a number. He says, but it's not a window; it's a square. Anyhow, so they discuss at some point. Przemek wants to get to the essence and says, look, two windows are equal 64. Therefore, one window is 32. Well, you know, you subtract 12 from both sides and you see that two windows are equal to 64. But are the numbers in the windows? Two windows are 64. So one window, I'm sorry. Oh. I'm sorry. Okay. Right. So in other words, one window is 32 and window again. And at that moment, Przemek gets an idea. That's right. Look here. An elephant is equal 64. Therefore, what is one elephant equal to? An elephant, says Bart, that becomes interesting, right? And he says, one elephant is 32. I understand now, so now the equation. But Przemek doesn't let him go yet and says, if two elephants are equal 60, then what one elephant is equal to? An elephant, well, one elephant is 30. I see it now equation, and here we have a big aha moment, right? And so on. So let's look at it, right? This is a dialogue that it's a very interesting dialogue for a couple of reasons. One of the main reasons is that we see here, those are boys of 10 years old, but Przemek is extremely good tutor, right? What he realizes after a while that the traditional way of explaining either by intervals or by the boxes like in the book doesn't work with Bart, right? Doesn't work. And on the third try, he picks up the elephant. Now, what did elephant come from? Well, the elephant came from the following situation. The person who was observing those two boys had a little desk, right? And on this desk, there were two figurettes. One was of little piggy, and another was of elephant. And well, my understanding why he chose an elephant and not the piggy is very simple, right? Because piggy is quite well, as I said, it's from Poland. Piggy is quite well known in Poland, but elephant so-so, right? Because, well, we don't have them here. We see them in the movies, we see them in the zoo, but we don't have this direct experience, so it is somewhat unknown to us. And it is this unknownness of the elephant that created a hidden, well, let's say, was it hidden or was it made by the Przemek imagination, right? He picked up the elephant, and it's interesting, right? Because that says about his own intuition being excellent as a tutor, right? And what is also interesting here is that at that moment, Bart starts getting it, right? And finally, he understands. And what does he understand? Well, he understands the concept of the unknown. That was the big issue here. He doesn't know, he didn't understand what does this X correspond to, right? So So here he grasped it, right? He grasped that. And then the question is, what are here those two matrices of experience? And that's, we see it. On one hand, there is there is a matrix of the unknown together with the whole logical structure of the equation, linear equation. And on the other hand, there is a matrix of experience of an elephant, right? I mean, elephant with big ears, right? With an interesting nose, right? Big and all, right? Two different. This is an elephant belongs to the perceptual framework, whereas unknown belongs to the logical frame, algebraic logical framework. So here are those two unconnected, really unconnected matrices of experience that get connected by the concept of unknown, right? Which tends to occur both here for the logic, for the equation, and here, in my opinion, for the elephant who is quite unknown in Poland. What else is important here? This, by the way, this aha moment we classify as mild aha moment, sort of like the lowest in our classification, because here is just one very simple connection, right? Of course, Bart understood something, right? But it's a sort of very small, very minimal, despite the fact that it's so important, right? One simple connection, and we call it mild aha moment. Because as I will go in the next one, you will see that connections are those elements that we use for description of the depth of learning. Here is Kim aha moment, right? I want to point out something else before I even start, that this particular moment, the student is by herself with it, in distinction to the previous case, right, where the aha moment was sort of facilitated by the tutor. And that corresponds to two different methods of facilitation of aha moments, right? And well, what is the problem here? The problem is the question asks how many stars will be in the pattern 12 and how many stars in pattern 121, right? And what we see here, the two different matrices are immediately visible, right? Namely, one matrix of experience are natural numbers which number the patterns, and another one is, of course, the shape of the patterns. It's something connected and yet different, right? So here are those two disconnected matrices of experience, right? I also want to say that as I'm going through the discussion, here, I point out to those four stages of Wallace-Adamart theory. Now let's see what happened here, right? She says, I was lost. I added up all stars for each number, compared them to each other, and tried to figure out the pattern. I drew diagrams that made no sense. I tried to use formulas that I have memorized, placing n's, n minus ones, and n plus ones anywhere, but that wasn't giving anything. Everything I thought, I remember, was completely disintegrating out of my brain, and as minutes ticked, I began to panic. The exam was going very poorly. And then she is finally, I decided to skim, and that is very important moment, right? All of her work, right here, this is the process of preparation, right? I mean, she works, she cannot get, but she develops, right? She develops the background to whatever comes, right? But what is also now important, as I say, she finally decided to skim throughout the rest of the test and answered whatever she could, and then she will come back. And this is this process, what I mentioned before, of going away. It's extremely important to go away from the problem, because that gives our mind, our unconscious mind, as Kessler would say, it gives chance to work, right? And then she comes back to it, right? She says, during this time, by the way, when she comes back to it, and even when she was away from it mostly, right? She comes back, and then what does she do? Well, she looks at she wrote, and then she erased everything, right? Emptied it out, which is a good metaphor for what needs to be done for incubation, starts to draw more figures representative of the ones given. And this is the moment, this is the step of incubation, right? Because as soon as she started doing it, namely, most probably, I imagine that her awareness was at that moment very much concentrated on how to draw them, right? It hits her. She realized that the number of stars in the first row of any pattern was one larger than n, and they descended down to one. And let's look what she talks about, right? Here we have the number, the number of the pattern is 1, and here we have 2. The number of the pattern is 2, and here we have 3 dots, and so on. And that's indeed is the hidden analogy. And again, is it hidden? Was there before she looked, or was it created by her, right? That's something to really think about in general, right? What happens. But here we see very precisely how it happens. The question is how we're going to interpret it. So in any case, she understood how to work with those patterns, right? And then she very fast calculated how many stars was there, and how did she calculate it? Because once she had those patterns, she immediately recalled Gauss idea, right? And in the first class, they discussed Gauss idea. So here, the next connection immediately gets to be made, right? And the connection is to the, I'm sure everyone knows the Gauss idea. When he was more or less the same age as those 2 kids that we talked about in the previous one, namely what Gauss did, what was the assignment? The assignment was the teacher told them to add all the numbers from 1 to 100, right? And this is the 4th grade, so it's quite laborious, and there were no calculators, right? So what Gauss did, he wrote it in this and in one order, and then he wrote it in the opposite order, so that he noticed, right, that the sum of corresponding number always gives the same number of 101. And essentially he had it now, because he knew that to get the final answer, right, he has to multiply. But multiply by what? How many of those pairs are there, right? And of course, there are 100 pairs. However, they repeat, right? Here, 1 plus 100 here corresponds to 101, right? So they repeat twice. Therefore, you just take half of them, right? So he multiplies 101 by 50 and gets 5050 as the answer. Similarly, Kim did it, right? She didn't have to go up to 100. She was going up to 13, right? Because the number of the pattern was 12, but the first one was 12 plus 1. But once she understood, of course, Gauss techniques, that it was very simple, and she got the answer 91. Okay, so what is happening in this aha moment? That's a very clear aha moment, right? As I said, we know what are the unconnected matrices of experience. We know that the hidden analogy or imagined analogy is between the number of the pattern and the topmost row of stars, right? But what is important for me to indicate this example of the Wallace-Hadamard process, right? And we very clearly see the preparation. We very clearly see the conditions for incubation, and finally the illumination. Now, where is verification? Verification is right here. At the moment when she calculates, right? When she actually calculates the answer, that's verification, right? She uses this knowledge gained by aha moment that that we talked about, uses this knowledge and immediately applies it to the knowledge she has, and indeed she verifies, yes, it works, right? It works, she knows it's 91 and so on. What else is important about this one? We also classify it as mild aha moment, because it's a very simple connection, singular one, but undoubtedly this is a bit richer, seems to me, than the previous moment. And that has to be taken into account. So as I am talking about the process of assessing the depth of knowledge, at this point we are doing it purely on the basis of connection. I will make the connection of this with the Piaget-Garcia triad in a minute. Now here we have also a dialogue. So again, what I want to indicate, this aha moment, similarly to the aha moment of the elephant, is aha moment where something happened to understand. It's not so much solving of the problems that requires much of work, but rather to understand the context of the problem. And that is very important for me, because it says that aha moments do not occur only when we have a problem to solve. They also occur when we want to understand something. Okay. So here is the function, right? F of x square root of x plus 3. And the teacher is asking, can all real values of x be used for the domain of the function square root of x plus 3? And the student immediately responds, no, negative x's cannot be used, right? And we know what the student is referring to when we introduce the radical, right? We say, well, f of x equals square root of x, and that immediately means, right, that x cannot be negative, right? And here the student does it. It's a simple misconception, but it's nonetheless a misconception, right? So then what does teacher do? The teacher tries to lead her to the cognitive conflict, right? He asks, well, what is it for -5? Is no good. What is it for -4? Is also not good, right? But how about -3? Right? And here a student thinks for a minute, because she has to calculate it and realize what's happening, that it's square root of 0, and says it works here. And then the next question is -2. It works here too. And then a moment later, that's here when I attribute the aha moment to her, those x's which are smaller than -3 can be used here. So what happened, right? What happened? Well, we'll talk maybe a bit in a minute. And what is important is that the teacher doesn't stop here. And that, I think, he should be congratulated, because here is asking the next question. What would happen if he gives square root of x plus 1? And the student finds it out. Smaller than 1 cannot be used. And finally, the teacher asks for the general form, right? This is the general form of this problem. And the student realizes smaller than a cannot be used. That is a very, very nice aha, except I must say that people from this Gestalt approach, they distinguish the possibility of so-called hybrid aha moments, and hybrid aha moment is a moment when we don't know whether it was the spontaneous jump or whether it was a conscious process of calculating. So we assume that, well, it could be both. That's why it's called hybrid, right? And here, as you see, well, what is the connections? Let's just think for a minute what were the connections here and what were the matrices that were made that became connected, and what are they? They are, in the first part of conversation, right? We have the values of the unknown less than necessary. And here we have more or equal than necessary, right? So those two separate matrices of experience get connected. And as a result of this connection, we have understanding, right? This process here, I attribute as a preparation. This is really a preparation for the illumination that happens here. But where was the incubation? During this moment that took the student to realize, to find out, to see what is happening here. That's the first one. But then when later she comes to the question square root of x plus 1, she does another comparison, right? Namely, the comparison with square root of x plus 3 and with square root of x plus 1, so that out of those two, she can very easily generalize, right? Generalize to the general form of the type, right? Because of that generalization and because of two types of connections that she made, well, we call it a strong aha moment, precisely because it went up to the generalization, and that's a major achievement in the process. There is also those letters in red, right? And those letters in red refer to a concept that's very much behind this whole classification of aha moments. Namely, it's called triad, Piaget-Garcia triad, which really describes the process of conceptual development, namely how ideas develop to their ultimate general manifestation, right? And it has 3 stages. They are called intrastage, inter, and trans stage, right? And they correspond to this. Namely, in the intrastage, as Piaget asserts, attention of the thinker is focused on the individual particular problems. They are not connected to each other, and we see indeed when the teacher is asking her those questions, they are not connected for her. The connection, okay, happens at this moment, at the moment of illumination. And by that process, she is entering what is called interstage. And interstage is exactly that stage of thinking when those separate particular cases get connected into one whole, right? But what is important that this one whole, while everything is connected, it's still not completed in a way, because we know that there is some deeper idea behind that. And finding these deeper ideas as she did leads to the trans stage, which means that the all connection is transcended into one general idea, right? And that's why we use this, right? Because it tells us, well, using this, we can say something about the depth. I don't think we can say everything, but we can say something about the depth of this of aha moment. And here we see the depth here as being strong. I think, it's strong by association, strong aha moment, and it's strong precisely because it reaches so far. In other words, we can also talk about that this whole process, cognitive process, is kind of a vertical nature in the language of Freudenthal, right? And at the next aha moment, I will show the other one that has this horizontal mathematization nature, right? Which is just to rediscover the concepts that we know from the literature, right? What else is important here? I think that's it. One thing that is important, I want to point again the attention to the process of, well, it's called sometimes how is it called, scaffolding, right? Scaffolding by the teacher or guiding the students. what is very important, you see, it's precision of this, right? The precision, and what I mean by that, it is no more and no less is set so that the student can make the next step on her own. This is very important, that in the whole process of say, scaffolding, it must be done in such a way, if it comes to the creativity, that at each step there is enough of intellectual space for student to make the step on her own. And similarly, like in the first one, when we had elephant and two students, again, the precision of Przemek was really beautiful, right? He hit immediately into that hint that helped, right? The teacher here was leading the student along by asking questions, right? Was leading the student towards it, right? And again, the questions seemed to be extremely precise because they worked, and they worked without major problems. Okay, the time is passing. I have the last aha moment to show. Here it is, right? First aha moment is a standard, well, it's a standard new type of problems, right? When we want students get involved physically into it, right? Then we ask questions, more complicated and so on, hoping that this way it will lead students to deeper understanding. And you see what's happening here, right? Again, we have stages, right? Stages of the pictures, right? And we have this invert, and we have this well, fir tree, right? Choinka in Polish, right? And the question is to find the number of units squared from understanding how it is built. So here it is, right? Then the question is to calculate the number 4. Then the question is to calculate stage 5. And the student answers, well, stage 5 is bigger. It has 30 units. And I don't know whether she actually had drawn it for herself or not. We'll see in a minute. She also knows how the pattern is growing. She knows well. And then the question is, how many unit squares are needed for the stage 10? And here she answers that, well, she needs 110 unit squares, and she found this answer from that pattern. So in other words, after first 3 or 4, she understood something, right? She understood that the number of square units is simply this formula, n plus 1. Right, and she can easily calculate the stage 10. Then comes the last question, which is important here, right? Because the question is, well, you have exactly 274 units to make up a fir tree. And the question is, what is the number of the pattern, essentially? Also, the question says he is wrong. Explain to him why is he wrong. And she has a very simple explanation. Look, if you take stage 16, you get 272. If you take stage 17, you have 306. And that means the 274 cannot fit. However, what is very important that at this moment, she has a tremendous aha moment that she wrote to me right after experiencing it. And she says, I just realized that the formula I got from the pattern was a factorized expression. And if I multiply it and put the unit squares on the right-hand side, I also have something like an algebraic expression, exactly the trinomial expression, which also can be factorized, right? And it, whatever there is, equals real numbers. For example, she gives one equation from the second, I think, from the second drawing or third, right? n plus 1 equals 12. She transforms it into quadratic equation and she factors it, right? And then she goes a couple of others, right? The one that has 20 units, she factors again and higher. And then she says, look, when it comes to n squared plus n minus 274, it cannot be factorized. So this is the second, right? This is the second method of answering the same question, right? The last question. And let's look at the structure, right? There's something very interesting, namely that she realizes that there is a connection between algebraic expression and the trinomial expression, quadratic trinomial expression, right? Namely, what is the connection? Both of them can be seen as factorized, right? So this hidden analogy was here a process of factorization or symbol of factorization, right? And what are the matrices that are connected? Well, in my opinion, it is those are algebraic expressions on one hand, and on the other thing, quadratic equations, right? Which she connects, right, to each other. And then comes the realization that, again, it cannot be the answer to 74 because it can, the corresponding quadratic equation cannot be factorized. So this is rather rich. This is rather rich aha moment, right? It is also very important that it doesn't happen when we solve original problem, but is another solution. And here we see in practice this flexibility of thinking, right? I mean, clearly she had some divergent thinking here. What else is important? We judge it as a normal aha moment, right? Because why? Why not normal and not the real strong? Because you see, although she made very, in my opinion, quite important connections, right, between the algebraic expression and quadratic expression, and she knew how to factorize, she didn't entirely know that those are the quadratic equations and that numbers in factorizations are actually solutions, right? So she stayed in this interstage without pulling the general expression out of it. And that's why we classify as normal, right? Which is she stayed within the interstage of the Piaget and Garcia triad. Anything else that I should say, maybe? No, I said all of this, right? There are some interesting things. Well, okay. So I would like, at this point, I can finish. There are things I may be able to say later, but the time almost is up. So I really invite people to tell me something about this story. Thank you very much.